Imagine this, you're on Earth right now, but in a matter of days, you could set foot on Alpha Centauri, more than 4 light-years away. No generation ships, no cryosleep, no biological warp time. Warp drive, the technology once only in science fiction, could make interstellar travel a reality. But this isn't just futuristic science. It's a big question. How would our lives, society, and morality change when space and time are no longer barriers? Today, we dive into possibilities that once seemed impossible. From pure physics to social and existential impact. Are we ready for a future that might be too fast, too vast, too warp? Have you ever stopped to consider what it truly means to travel faster than light? For over a century, physics told us it was impossible. Einstein's theory of relativity sets a hard limit. Nothing can move through space faster than light. But in 1994, Miguel Alcubierre, a Mexican theoretical physicist, asked a bold question. What if we could manipulate space itself rather than move through it? His answer was elegant and mind-bending. The Alcubierre Drive proposes that a spacecraft could sit inside a warp bubble, a region of warped spacetime. Space contracts in front of the bubble and expands behind it, effectively moving the bubble forward faster than light. Within this bubble, the ship never locally breaks the light-speed barrier, avoiding the time dilation and causality paradoxes that normally plague FTL travel. But here's the catch. To hold such a bubble, the universe requires exotic matter, a form of matter with negative energy density. So far, no one has observed this matter naturally, though the Casimir effect demonstrates tiny amounts of negative energy between two close metal plates. The leap from microscopic quantum effects to macroscopic warp bubbles is enormous, almost unimaginable. Let's consider scale. Early calculations suggested that to move a small spacecraft, the energy required would be comparable to the mass of Jupiter. More recent work by NASA's Dr. Harold "Sonny" White shows that, by adjusting the shape of the warp bubble, energy requirements might be reduced to something comparable to the mass energy of Voyager 1. Still enormous, yet far more approachable, and enough to spark serious scientific discussion. Beyond raw energy, there are questions of stability and control. How do you create and maintain a warp bubble without catastrophic collapse? How would a ship safely enter and exit this region of warped spacetime? Even tiny miscalculations could have unpredictable, perhaps fatal, consequences. And here's what makes this truly fascinating. Thinking about warp drive doesn't just challenge engineering, it challenges our understanding of space itself. If spacetime can be bent, manipulated, and folded, what does that say about the universe? About the limits we assume exist. About the line between science and imagination. Warp drive, even as a theoretical construct, forces us to ask, could humans ever truly master the cosmos? Could we one day surf the waves of space-time itself? Or are we glimpsing the boundary of what is possible, tantalizing yet just beyond our reach? As you consider these questions, remember, every speculative calculation pushes the edge of human curiosity, inspiring both science and imagination. History is full of ideas that once seemed impossible. Imagine the Wright brothers in 1903, standing on the sands of Kitty Hawk, flying a machine heavier than air. Most people thought human flight was a fantasy. Today, billions of people fly every year across continents and oceans. Or consider the atom bomb. Early 20th century physicists only dreamed of harnessing the power locked inside atoms. Decades of theoretical research, experimentation, and engineering led to one of the most transformative, and terrifying technologies humanity has ever created. Even the internet, something most of us take for granted today, began as an abstract project to connect research computers. What was once speculative, almost unimaginable, is now so ordinary that we hardly think about it. So, when we talk about the Alcubierre Drive and warp bubbles, it's useful to remember these analogies. Many technologies started as bold, theoretical ideas that seemed absurd until someone tried, tested, and refined them. Physics sets boundaries, but history shows us that those boundaries can be stretched when imagination, mathematics, and experimentation converge. The question we should ask ourselves is this: what other, impossible ideas might someday shape reality? Could the warp drive of today become the airplane, the atom bomb, or the internet of tomorrow? History tells us that to explore the unknown, we must first allow ourselves to imagine it. Now let's imagine that warp drive isn't just theoretical, but suddenly becomes a reality. What happens to civilization when humans can traverse the stars in days instead of millennia? First, consider geopolitics. The first nation, or corporation, to master warp drive would hold unparalleled power. Space would become a new arena for dominance, with strategic access to planets, moons, and asteroid belts. Traditional military doctrine would be appended. Speed, distance, and the ability to appear anywhere in the galaxy in days could create a new form of global, or interstellar, superpower. Economically, the implications are staggering. Imagine mining resources from asteroids, moons, or distant planets. Rare metals like platinum, gold, or even exotic elements could be brought back to Earth with unprecedented efficiency. Supply chains would stretch across light years. Entire new industries would emerge: interstellar shipping, planetary colonization, and resource exploitation on a cosmic scale. The very definition of wealth could change overnight. But it's not just politics and economics. Think about culture. Colonies on distant planets would develop unique identities. Language, traditions, and even ethics could diverge in ways unimaginable today. Earth, once the center of human civilization, might become just one hub among many. What does it mean to be human when your birthplace is no longer the sole reference for culture, history, or values? There's also the question of law and morality. How do you govern interstellar travel? What rules apply when people can move faster than any authority can follow? Crime, smuggling, and interstellar diplomacy could all face entirely new challenges. Even philosophical questions arise. If we can live among the stars, how do we value life, home, and time itself? Finally, consider the broader existential perspective. Warp drive could accelerate human expansion into the galaxy, perhaps increasing the chances of encountering extraterrestrial life, or risking conflicts we can't yet imagine. Every decision about how we use such technology will have consequences that extend far beyond our planet. So, warp drive isn't just a technical problem. It's a societal, economic, cultural, and philosophical revolution rolled into one. It asks not only, can we, but should we, and challenges us to rethink our place in the universe. As we contemplate the possibility, one thing becomes clear: the future we imagine today may soon become the reality of tomorrow, and civilization itself would never be the same. If warp drive becomes reality, it won't just change where we go, it will change how we think about ourselves. Imagine standing on a colony world, looking back at Earth. The place that once defined human civilization is now just one dot among countless stars. How does that reshape our understanding of home, identity, and belonging? Science fiction has long speculated about mind upload, consciousness transfer, and post-human evolution. Warp Drive forces us to confront these questions in reality. If interstellar travel becomes commonplace, will humans need to evolve, biologically, technologically, or mentally, to survive and thrive across light years? Consider time. Even at warp speeds, communication across light years has delays. Families, governments, and societies would experience desynchronization. What does it mean to live in a universe where your friends, colleagues, or children are years, even decades, apart in experience? And then there's the question of the great filter. If warp drives are possible, why haven't we seen evidence of advanced civilizations elsewhere? Are we early explorers in a quiet galaxy, or are there dangers we have yet to comprehend? The existential implications are profound. Warp drive isn't just a tool, it's a mirror. It reflects our curiosity, our ambitions, and our fears. It challenges our ideas about time, space, morality, and survival. It asks, what does it mean to be human when the universe itself can be traversed in ways that were once unimaginable? So as we imagine warp bubbles and distant colonies, we are also imagining ourselves, our potential, our limitations, and the profound questions that define our existence. Warp drive is more than just a theoretical technology. It's a window into the possibilities of our universe, a challenge to our imagination, and a mirror reflecting what it means to be human. From the physics of Alcubierre bubbles to the societal, cultural, and philosophical consequences, we've explored a future that is both thrilling and uncertain. One thing is clear: if warp drive ever becomes reality, civilization will be forever changed. So ask yourself, are we ready? Ready to not only traverse the stars, but to rethink space, time, and our place in the cosmos? The journey may be long, the questions profound, but the possibilities endless.